Hello, this is Mrs. Sharrow, and today we are going to look at 5.4 Part 2, which is a lesson covering a new process for dividing polynomials. The method is called synthetic division, and many students find this method to be easier, faster than long division. However, it doesn't work 100% of the time. So what we are going to see here at the very start is that this process can be applied to some but not all division problems. So the certain scenario that synthetic division works for is that it has to be dividing by a linear factor in the form x minus c, where c just represents an integer, which is a positive or negative whole number. You can see that in these two examples here. We've got x plus 2, x minus 1 as the linear factors that it's being divided by. A situation where synthetic division would not work would be if you had a leading coefficient other than 1. So if you look at this one over here, the long division process only works in this case when we're dividing by 2x minus 1. Also, if you were dividing by a non-linear polynomial, so if you were dividing by something, let's say that was quadratic, if it involved an x squared, synthetic would not work for that situation either. So we still need long division because it will work for those other cases, but synthetic division can be a little easier and maybe a little faster if our problem meets those synthetic division requirements. All right, so let's take a look at a few problems. So in the first one, let's go ahead and start by looking at what this is being divided by. So we have a bigger polynomial here. It's being divided by x minus 1. What I always want you to look at first is what it's being divided by. Notice how it looks like it is a minus 1. We are going to change that to the opposite sign, and we're going to put that here in the upper left-hand corner inside of a little box. So let's go ahead and make a note here that it's going to turn to the opposite sign. And you don't really have to put the plus sign in front of the 1. You can just write it as a positive 1. Then we are going to write some other numbers across the row. We are just going to take the coefficients of the polynomial at the start, which means we're not going to be putting any x's or variables in here. So we are going to put positive 4, leave a little bit of space, and then we're going to do negative 3, leave a little bit of space, got positive 2, and negative 3. So those were just the coefficients of our original polynomial. Then we're going to leave a little bit of space below those numbers, and then you're going to draw a horizontal line at the bottom. Now listen and watch carefully. This is how the process works for synthetic division. We're always going to begin by bringing the first coefficient number straight down to the bottom of the line. In this case, we're going to bring down the 4. Then this 4 is going to multiply by the number in the box. So that 4 is going to multiply by 1, and we're going to put the answer right here in that position. So in this case, 4 times 1 is 4. And now we're going to add the numbers in this column. So we're going to do negative 3 plus 4, which is 1. Now we're going to repeat the process. The number on the bottom is going to multiply by the number in the box, and the answer is going to go here. In this case, 1 times 1 equals 1. Then we're going to add the numbers in this column. That 2 plus 1 turns into a 3. Repeat the process one more time. The number at the bottom multiplies by the number in the box. The answer goes over here in the next position. In this case, 3 times 1 is 3. When we add the numbers in the last column, we see that it is equal to 0. Now, I like to do a little box for that very last number to sort of separate it out, because that is going to represent the remainder. Now, as we saw yesterday, is that if the remainder is equal to 0, it just means that x minus 1 is a perfect factor of what we started with. Now we need to do something with the 4, the 1, and the 3. So this is going to represent a polynomial that is 1 degree less than whatever we started with. Notice how we started with something that was a degree of 3, so 1 degree less would be a degree of 2. And these are going to be the coefficients for that polynomial. So it's going to be 4x squared plus 1x plus 3. And this right there would be our final answer. Now let's try this for a new problem. One thing that we have to be on the lookout for, just as we did with long division, is if there are any missing terms. And in this case, if we take a look at this polynomial here at the start, we see that we're actually missing two terms. We're missing x to the third, so we need to think about a 0 being in that position. And we're also missing the regular x term, so we're going to put a 0 in that position as well. All right, we're going to start the same way by looking at what we're dividing by. So we're dividing by x plus 2. So we are going to take that plus 2 and we are going to turn it into a minus 2 when it goes in the box. Now to list out the next set of numbers, we are going to look at the 5 values here that are highlighted in blue, no x's, but we are going to list them out across like this. There's really an invisible 1 at the very front there, so we've got a 1, 0, negative 6, 0, negative 27. All right, now we're going to go through our process. So we're going to take the first coefficient, in this case it's 1, we're going to bring it down to the bottom. 1 times negative 2 is negative 2. Add the numbers here. Negative 2 at the bottom, multiplied by negative 2 in the box is positive 4. Add the numbers in the column. We have negative 2 times negative 2 again, which turns into another positive 4. Add the numbers. And finally, we've got 4 multiplied by negative 2, which will be negative 8. Now, this one does have a remainder of negative 35. Okay, so let's go ahead and write this out as our answer. So notice how this one started with a degree of 4. So this answer has to be 1 degree less. So it's going to be a degree of 3. Just like that. Now for the remainder fraction on the end, because it's negative 35, we can think about subtracting the remainder fraction. Negative 35 is going to go on the numerator, and then whatever we divided by, in this case we divided by x plus 2, that's going to go on the denominator. The last thing we're going to look at today is called the remainder theorem. This is an application of the synthetic division process. The theorem states that if you divide a polynomial by x minus a, then the remainder is p of a. So let's try this out. In the next problem, we are going to want to find p of 4. According to the remainder theorem, that means that we are going to divide by x minus 4. To do our division, we're going to go ahead and turn it back into a positive 4 when we put it in the box. And looking at our coefficients, listing them out, we have 1, 6, 9, 3, and negative 3. If you ever have a subtraction sign in front of a number, make sure that you bring that down as a negative. And we didn't have any missing terms here, so we don't need to fill in any zeros. All right, we're going to go through our synthetic division process. Bring down the 1. 1 times 4 is 4. Add the column to get 10. 10 times 4 is 40. Add the column here to get 49. 49 times 4 is 2. Hold on, I'm looking for my notes here. Where's my notes? Okay, no, it's not in the 200s. I was going to say it's 4 less than 200. It's 196. And then add the numbers here in this column to get 199. Multiply that by 4 and we get 796. Add the last column and we get 793. Now the only thing we have to pay attention to on this remainder theorem problem is just the actual remainder. And so we're going to write out our final answer like this, that p of 4 is equal to 793. And so we can actually ignore the rest of the values here. On these problems, you don't need to write your final answer out with the x's. Now, a way to check this is to go into your calculator And if you wanted to find P of 4, you could plug in 4 for every x value that you see, and you should get the same answer of 793. However, the synthetic division process, I think it's super quick, it's super fast, it's even easier than the amount of time that it would take you to type all of that into your calculator. So it is a shortcut way to get the value of P of 4. All right, let's take a look at the last one here. So here we want to find P of negative 2. So we're going to divide by x minus negative 2, which is really the same thing as x plus 2. All right, so if we're dividing by x plus 2, it's going to turn back into a negative 2. When we start to list out our coefficients, we've got 5, negative 2. I'm going to put in a 0 because we're missing the x term. And then we've got an 11 at the end. We're going to go through our division process, bring down the 5, multiply it by the number in the box to get negative 10, add the column. Negative 12 multiplied by negative 2 is positive 24, add the column. And then 24 times negative 2 is negative 48, add the column here, and we get negative 37. That is our final answer there. So we're going to say that the answer to P of negative 2 is equal to negative 37. And just as we saw before, you can actually ignore these values out in the very front. All right, now I want to finish by actually showing you what the remainder theorem problem is going to look like in your homework assignment for tonight. So this is a sample problem that you will see on tonight's assignment, number 33. So it says to use synthetic division and the remainder theorem to find P of A. So what it's doing at the start here is it's showing us P of X, and then it's telling us the value of A at the end. So we want to find P of A. So we're just going to go ahead and add this in, that if A is negative 2, then we're going to be finding P of negative 2. So just as we did in the other examples here, we're going to be dividing by x plus 2. Okay, so if we divide by x plus 2, we're going to turn this back into a minus 2. We're always going to look for missing terms. Now look at this one. Sometimes the missing term is the value at the end. So it could be the constant term. You could have a 0 at the very end of your list. Okay, oh, look at this one. Okay, so we got a remainder of 0. That's okay. That just means that that is the value of P of negative 2. It's just going to look like that. Remember that we can ignore these ones. Now, for the first part of your assignment, it's not the remainder theorem. It just simply wants you to divide with synthetic division. So for those first 4 problems, 21, 23, 25, and 27, it's going to be just like these ones, okay? So you're going to write out the whole answer, including the x's and all of that. When it starts at number 33, that's the only part where you're going to start doing this remainder theorem. All right, let me know if you have any questions on this, and thanks for making it to the end of the video.